Hello and welcome everybody. Today I'll try to explain as simply as possible what mathematical induction is. But before I get to the mathematical part, let me compare it to something we do in our everyday life. Let's say someone gives you a set of numbers. 1, 2, 3, 4, 5, and 6. And he asks, well, what is the next number? Well, you obviously are going to say 7. And this is what is called the inductive reasoning. And you see a pattern here, and you assume that it goes on until the 7th term. Well, a mathematician could say, well, maybe the pattern stops right here. And this is where mathematical induction comes in. You prove that this pattern goes on into the domain. Okay, so let's get to it. The mathematical induction is divided into 3 steps. The first step, prove the statement is true for starting value. 2, assume that the statement is true for k. And 3, use the assumption above to prove that the statement is true for k plus 1. Now this might seem, for some of you, a bit odd. How does that prove anything? Well, if you look at the step 2 and 3, it says that if one is true, then the next one will surely be true. And in the first step, we proved that the first one is true. So the second and third step imply that the next one is true. So if the first one is true, the next one has to be true. Well, then the next one has to be true, and the next one has to be true, and that goes until infinity. And that's basically how mathematical induction works. Now, there are 2 types of mathematical inductions that you can encounter. And this is you have to prove that some sum is equal to something, or that something is divisible by something. So I'm going to give one example for each. So the first example is the sum r equal 1 to n r squared is equal to n over 6 times n plus 1 multiplied by 2n plus 1. Now it says it holds true for natural numbers. So the starting value will be 1, as it is the first natural number. Or 0, because some say that 0 is also a natural number. But in this case, we're just going to have to assume it's 1, as the sigma implies that it's 1. Okay, so the first step. We prove it is true for 1. So, the sum r equals 1 to 1, r squared is equal to 1 over 6, 2 multiplied by 3. Well, that's 1, because that's 1 squared equals 1. Okay, proven. Now the second step. The second step says, assume that the statement is true for k. So, let's plug in k. R equals 1. Here is k, r squared. That is equal to k over 6, k plus 1, and 2k plus 1. Now we assume this is true. Okay, so this is true for us. We don't know if it's true, but we just assume that. Now the third step says that we have to prove that the statement is true for k plus 1. So here we have k plus 1, r squared, and that is, we have to prove that this is equal to this. 2k plus 3. We have to prove this is equal to this. Now, as you can see, this is as sigma notation. So actually, we can change it. Let's change it up a bit. Now, you can notice that it's gonna actually simplify into something very nice. And we add k plus 1 squared. Now what is that equal to, this whole thing? Well, that is basically equal to this. because we just add one more term, and that one more term is k plus 1 squared. So that is equal to k plus 1 r equals 1 r squared. Now we're gonna use this. Okay, so we're gonna plug this bit instead of this. We add this, and if this whole thing, this thing turns out to be this, then we have proven that this statement is true. Okay, so let's do it. It's k over 6 multiplied by k plus 1 multiplied by 2k plus 1 plus k plus 1 squared. Now we can take k plus 1 in front. That's going to be k over 6 multiplied by k by 2k plus 1 plus k plus 1 from here. Okay, now that is equal to, let's multiply these and put this into the fraction. So it's going to be k plus 1 multiplied by 2k squared plus k plus 6k plus 6. All this over 6. And that is equal to, okay, so we can actually take 1/6 in front, so it's going to be k plus 1 over 6. Okay, so we already got this little part, and inside we have 2k squared plus 7k plus 6. Now if this little bit is equal to this, then we're set, proven. Okay, so let's see if this is equal to this. K plus 2 multiplied by k, 2k plus 3, that is equal to 2k squared plus 3k plus 4k plus 6. That is equal to 2k squared plus 7k plus 6. Proven. That is equal to k plus 1 over 6, k plus 2, 2k plus 3. Okay, so the mathematical proven. Okay, great. Now let's move on to the next type of example that you might encounter, and it's divisibility. And I also have an exercise for it. And we're gonna prove that 3 to 2n plus 7 is actually divisible by 8. And it's for n for natural numbers. Okay, so the first step, as you remember, we are checking if it's true for n equals 0, the first natural number. And it's gonna be 3 to the 0 plus 7, that's 8. And that's obviously divisible. Great. Okay, the second step. We assume it is true for k. So 2k plus 7 is divisible by 8. And what that says is that this is a multiple of 8. So 8, let's say a. Okay, so this is true. This is some sort of 8 times something. Now the third is that we have to prove it is true for k plus 1 using the assumption. Okay, so we're gonna have to look for this somewhere in 3 to k plus 1 plus 7. We have to look for this somewhere here. Well, that is basically equal to 2k plus 2 plus 7, and that is equal to 9 times 2k plus 7. Okay, and that's what it tells us. Now look here and here. Now we have to somehow put this somewhere over here. Well, the common thing we have here is 3 to the 2k. So let's actually come back to this and put the 7 on the other side. 3 to the second to 2k is equal to 8a minus 7. Okay? Now let's plug this in. It's gonna be, it's gonna be 9 times 8a minus 7 plus 7. Okay? So it's basically 9 times 8a, which is obviously divisible by 8 because there is 8 here, and minus 9 times 7 plus 7. So we can see that it's basically gonna be 9a minus 7. So it's divisible by 8. So it's proven. So these are this was the mathematical induction. I hope I was fairly clear. Thank you for watching.